All right, hi folks, this is Larry Maslino. I'm recording a video for Section 3.5. This has to do with higher order derivatives. So we've been talking about finding the derivative of a function. So we started out with f of x, and we're able to calculate the derivative function. Remember, derivative function is the slope of the tangent line to the function at a certain x value. Well, what we want to talk about now is the ability to calculate what's called the second derivative. We're going to denote that as f double prime of x. We're going to see why this is useful. It's going to turn out this is going to give us information about the shape of the function, the shape of the graph of the function, especially with respect to what's called concavity. All right, well, you can probably imagine that when we go to take the derivative of the derivative, we're going to be calling that the second derivative. So once you have the derivative calculated, if you take the derivative of that function, we'll get f double prime. You can imagine taking the derivative of that function, that'll give you f triple prime. We could also write this as y prime, y double prime, and so on. Do a quick example here. Let's say here's the original function, and we want to find the first derivative. We call that f prime. Well, you remember using the power rule. So the derivative of x to the 5 is 5x to the 4, and so on. Now let's find the second derivative. The second derivative means take the derivative of the first derivative. So let me take the derivative of 5x to the 4. Well, that gets me 20x to the third. So by taking the derivative of the first derivative, that yields a function called the second derivative. And of course, we can keep doing this again. Let's take the derivative of the second derivative. That's going to give us the third derivative. If I take the derivative of 20x to the third, that gives me 60x squared. So what I'm really doing is repeating this derivative process multiple times to generate these higher order derivatives. You can even keep going. Notice here they actually calculate a fourth and fifth derivative. We're not going to do that. We mostly work with the first and second derivatives. All right, let's do a couple of WebAssign examples. First one is giving us this function to begin with. Here's f of x. All right, let's calculate the first derivative. I'm really just going to use the power rule here. So I'm going to bring this negative 0.6 with me because that's just a constant in front. Bring the 2 down in front as a multiplier, and then subtract 1 from the exponent, so that's x to the 1. Then when I take the derivative of 0.2x, that's just 0.2. And then the derivative of 8 is 0. So what I'm ending up with here for the first derivative is negative 1.2x plus 0.2. Now they're also asking me to take this to find the second derivative. Well, the second derivative means I'm going to take the derivative of the first derivative. But when I take the derivative of negative 1.2x, I just get negative 1.2. And then the derivative of this constant, of course, is 0. So the second derivative just turns out to be negative 1.2. All right, let's do the bottom example. Again, they want us to find the first and second derivative. Here, I just have to be careful to use the chain rule. So let's find the first derivative to begin with. Well, the chain rule says I should bring the 5 down in front, leave the parentheses as is. This is like the inner function. Subtract 1 from the exponent, and then I have to multiply by the derivative of what's inside. But the derivative of x squared is 2x. So you could see I'm ending up with this answer. Now I want to find the second derivative. Well, the second derivative means I have to take the derivative of the first derivative. Now for that, I'm going to actually need the product rule. So let's work through that because this is going to be a little tricky. Let me call this first part f and the second part G, because that was the naming convention we used when we wanted to use the product rule. And remember, the product rule said form FG prime plus GF prime. So let's do that. Well, F is just 10x, so I'm going to write here 10x. Now let me take the derivative of G. Well, the derivative of G is the derivative, let me circle this in red so you can see it. I need to take the derivative of this G here. Well, notice I'm going to need the chain rule for that. So I'm going to bring a 4 down in front, leave the parentheses as is, and subtract 1 from the exponent. Then I have to also multiply by the derivative of what's inside, which is 2x, plus G times f prime. But G is x squared plus 9 to the 4th. And then f prime is the derivative of this 10x, and that's just 10. I can clean this up a little bit. Let me just clean this up. Here I have a 10 times a 4 times a 2, so that's 80. I also have an x times an x, so that's x squared. And then I have x squared plus 9 to the 3rd, plus 10 times x squared plus 9 to the 4th. Okay, and you could just enter the answer that way for WebAssign. That answer actually is equivalent to what WebAssign is showing in this, in that green box there. It's really equivalent to what I wrote as the answer. So you can, or your answer, either way, WebAssign should take it in several different formats. All right. Let me help you set these up. I'm going to let you try these, but for number 7, you can either use the quotient rule here, or you can write it as, let me give you another option here. What I could do is rewrite f of x to get rid of the fraction. And the way I could do that is bring the denominator up to the top with an exponent -1. The reason I might want to do it this way is now I would use the product rule instead of the quotient rule. And the product rule is a little easier to work with versus the quotient rule, but you could do it either way, of course, and get the same answer. So when you apply the product rule, you should end up with this result. Then when you take the derivative again, now let me rewrite f prime of x. I could write f prime of x as 2. And again, I'm going to bring that denominator upstairs. So that would be 5x plus 2 to the -2. And now I could take the derivative of that function. Let's do it while let's go ahead and take the second derivative. All right, this 2 is a constant, so I'm just copying it down. This -2 comes down in front as a multiplier. Then I'm going to subtract 1 from the exponent, so that's a -3. The chain rule says I still have to multiply by the derivative of what's inside the parenthesis. The derivative of 5x is just 5. And you can see when I multiply this out, 2 times -2 times 5 is -20. And then I could take this parenthesis with the -3 and move that down to the bottom of the fraction if I wanted to. This is if you wanted to get rid of negative exponents. By moving that down to the bottom of the fraction, it flips the -3 to get positive. All right, let's look at the last example. Well, you remember when we're taking derivatives, we'd like to replace square roots using the exponent 1/2. So this is going to be 9 minus 3u to the 1/2. All right, let's take the derivative of this function. I'm going to need the chain rule here. So the derivative, let me bring the 1/2 down in front. Keep the parenthesis as is. Subtract 1 from the exponent, so 1/2 minus 1 is negative 1/2. But I still have to multiply by the derivative of what's inside. So when I take the derivative of that negative 3u, that's going to be a negative 3. And of course, this parenthesis with the negative 1/2, I could move down to the denominator. That would flip the negative 1/2 exponent to be positive 1/2. See, I would end up with this result here. Then take the second derivative to get the answer you see on the slide. I'll let you work that out. If you run into any trouble, folks, please email me and I'll be glad to help out. I hope this is helpful as you're working section 3.5 on taking second derivatives.